Okay. Sorry, I might be a bit tired. In any case, last stream I showed that I can in fact store a value of 1 using only what the CPU provides in terms of opcodes. I still have to add the CPU instruction, and I'm not looking forward to that because that means I have to figure out exactly how I want to set up CPUs. Setting changing. In any case, so that's nice and dandy. So I have tested some of the move operation. Need to test math operations. And you know what? I don't want to write down all the instructions by hand. But I suppose I will have to for at least a little bit. So, let's see. First, I can close a bunch of these that were open from last time. So what I want to do is a simple multiplication thing. Since there's no multiplication instruction here, that means I'll have to use adding. So let's see. A must be a register, B can be a register or immediate. So first I need to go ahead and load in a few variables. Okay, so I need to move, let's see, into register A. I would want to move one of the two operations. the operands of the multiplication. So let's say 5 is going to be in A and 4 is going to be in B. Then let's see into C, I move 0, and into D, I move 0. So this will actually test a few things. It will test addition, and it will test comparison. If I was smart, I would have did this. If I was even smarter, I'd use replace. So, at this point, we're going to use the add instruction. So, the first thing we're going to do is we're going to add to register okay. Going to add to register C, and what we're going to add is register A content. Then we're going to add to register D, and what we're going to add is the constant, or the immediate 1. Okay. If I remember correctly, a comparison can take place between two registers. Where's the compare function? Compare. Oh, they must be two registers. Okay. Okay. I mean, that's fair. You get like 4 registers that you can do whatever you want with. 0501. So 0501 takes in two registers. We're going to take in register 1 and we're going to take in register 3. Let me double check how compare, because I think compare sets the flag if equal. Hmm. What does SLP do that? Okay, it puts it to sleep. Hmm. All right, compare. So we take brand 1D and set to hidden text. Then if the second brand type is also a register, we set register status uh, to if register hidden technical is equal to the second, or the register that is resolved from this value, then uh, to register st or 0x0001, which means whatever is in register st plus also guaranteeing that this bit will be set. Otherwise, whatever is in register st but guaranteeing that bit will not be set. Okay. Then we have a conditional jump. Jump if flag is set. Which has the 0302, 0302. Jump if flag is set. This must be an immediate, and what we're going to do is $48. And the reason why I'm going to set it to 48 is going to make sense in a second, particularly because I'm about to explain it. Because by the time it gets to here, we need to jump if it's set, if it's equal. But we don't have a jump if clear, if I remember correctly. We only have jump if set, which means that we're going to need an unconditional jump that happens before. And we're going to put that unconditional jump right here. And we're going to have any other code that we want to execute be after that point. Actually, I think we start with privilege. So we can just go ahead and say We don't start with range. This must be a mistake. Yeah, down here we have privilege set to true. Any case. Right now, there's nothing to wake the uh, CPU, so we can just use sleep. But we still do need to store the result somewhere. Right, but first we should worry about this unconditional jump. 0301 for unconditional jump. We need that. These do not count or do not matter, so we need 8. No, we're still loading stuff in. 2x0201. And this is 20. Okay, so now we move. And we want to store. Hold on. 0x03. 4,000 will be the place I store this result. And the thing that I'm storing will be, let's see, this, right, register C. Then we'll store we'll write an instruction to put the CPU to sleep. I wish there was an instruction to just put me to sleep on command. Zero 0403. It would be very useful for me. And it takes no operand, but it is protected. So right, we should see memory address of 0x4000 has value 20. Okay, fair enough. It runs for 128 ticks, which is like 3 instructions. So let's change that. Hmm, I don't think this is correct. Let's take a look at system. Wait, hold on. Sorry. There we go. Now it should actually hit because before it was going to 255. I didn't realize that this was the UN 8. I thought it was already UN 32. I was wrong. Okay, we have the value 20 now. So we now have shown that I'm going to make another row. Copy this. Though I probably should use a number instead. But first, this works. This works. These two work. And this work. I don't know what about this one. Because right now I don't have any evidence that it doesn't go past. I maybe could claim that it shouldn't go past, but then again, that claim would be based off of my idea of it already having behaviors that I think it should have, and thus would not be very good to just assume. So, what I'm going to add right after this instruction is another move instruction. And what this is going to do is it's going to take A and move it into the same spot. If this sleeps, then we should see no change. But if it doesn't, then if it doesn't, and there isn't anything down the line to just randomly write the number 20 to that exact location, which is not happening, then we should be fine. Okay. Now I'm at least reasonably confident. I still thought I had the check mark. Okay, so I have no reason to believe that NOP doesn't just work because there's nothing to tell uh, the CPU to do something when that opcode would be present. In fact, it just sets the CPU clock back to 0. If there's not a specifically identified instruction. So let's take another look. First, we might also want to get push and pop. Might want subtraction. We want to test all of these. I think the easiest right now to test would be we look at MMC. Where is it? MMC. And see what its interrupts are. So we interrupt with param1 set to 004. If I remember correctly, B is param1 and C is param2. But I often remember things incorrectly, so I should not just trust myself on that. All right, param2. Then in the next cycle, param3. No, frick. Then in third cycle, that's this one. Sorry. IRQ out, which is the UN 16. The top half of which is a NMI in for devices typically. But let's see. This clock. That's the CPU clock. All right. Processors and IRQ out. Okay, I was incorrect. IRQ out, lowest at least significant bit. Sets NMI in. So here we are. NMI in. And okay. I really should just get a I really should write myself an assembler. I have the knowledge for what equals what. And I need a method to load up programs easier than manually writing them all out. 0.03, what was that again? Sleep. Useful, but currently we don't need it right now. So I will put it here. At the end where there's nothing it does. Okay, so a conditional jump to here, and an unconditional jump all the way to the top. This copies the variable over. This is the instruction after. So I want to interrupt the CPU, or sorry, I want to send an interrupt from the CPU. So I need, sorry, 0402 to send an interrupt from the CPU. Operand 1 type. A must be intermediate, so it's a 2. The rest of these are also going to be a 2, since I already know what I want. And error queue out. So this is going to be a 1. Then param 1 must be a 4. This can be literally anything in the world. So I'm just going to leave it. These two instructions shouldn't do anything. And this I am going to copy a few times. Let's take a look at MMC.h for 8 and C. Actually, this will not work. The reason why is because I have to move these around. There you go. So this will jump here. This will send an interrupt to the MMC. This will send this variable to the MMC, which will send it to base RAM. These two instructions do nothing, and then this will sleep. I put these here for spacing, just so that way if I need to put instructions there for further testing, I can do so easily. We should see these have the same value. 0x0000 wouldn't have the same value because that goes to ROM instead. But since our interrupt will cause floor bus A address to be true, and that will mean that uh, this will always just see it will see the top two bits not be set, particularly right here. So with that, I build, and let's see. Okay. Does an interrupt actually work then? I don't know. Let me go ahead and insert another one of these. All right, but we also want to get the interrupt. See? Very easy. Now the flag is set. I can just run this. I'm seeing a lot of interrupt in MMC, which I should not be seeing. Let me make sure that I placed that correctly. This is indeed placed correctly. In fact, this will only get from the first two bits. See? System.h. System C++. Processors 0, IRQ out. We equals 0x0001. You know what? Maybe I should tone down the calls I make to the step system. Let's see. Okay, hmm. Where does it start getting interrupted? Just trying to find where. I feel like it should be close, actually. But I'm not seeing it. Okay, we get interrupt in MMC twice. Uh, right after here. Hmm. Alright, so I know I need now to record the IRQ out. Wait, is it simply because I like forget to clear something? Am I in? Okay. Okay. Perhaps that was all that I needed to do. Alright, we're not seeing interrupts on every uh instruction, so there we go. So at this point we sleep. But two, one, then we do nothing for a while. Or uh, okay, it looks like here we had something. Wait, uh, maybe not. Maybe I read that incorrectly. Okay, okay, here we have an interrupt. Uh, we don't actually see this being said, so we have to solve what's going on. So, what do we do? Simple. We we spill the beans on what these are. I was about to say we spill the guts, but it's spill our guts or spill your guts in a particular case. But spill the beans. We spill the beans. I might be too tired to know what expressions are, and I should really just not use them in the first place because I'm just bound to get them wrong. Particularly, I think spill your guts is when you talk about something when you're drunk, if I remember correctly. Or maybe it's just when you're sad. I don't. And again, maybe that was just a context in, under which that phrase I have, or I have encountered that phrase. I think it's this one we get interrupt somewhere up here. All right, I param 1 and I param 2 are both 0 for some reason. Let's take a look. Processors 0, IRQ param 1, IRQ param 2. So, wait, no, it's in CPU H. No, it's an interruptible. I prime 1, 2, 3, 4, but output IRQ param 1 and 2. So we have dropped in MMC. Both of these are 0, which, let's take a look. Okay. So this is a set of operands we're working with. So nothing special because we don't do anything with that. This goes towards the MMC, which is correct. This OP2D is 4, indicating a median of 4. OP3T or OP3D of 0 because we don't use it. We could set it to any value, but okay. So it seems like the last failure point to consider is what happens in the CPU. So OP2D or IRQ param 1 is set to OP2D. If OP2T is 2, it is. So this should be, our IRQ param 1 should be 4. Then, let's see. Interrupt. That's why. That's why. Okay. Okay. It was because this was just setting it back to 0. I didn't realize because I set this to 0, and also 0 seems like a very default option, considering that this was also 0. I was like, yeah, okay, so I'm just not setting it, right? That might be the case, but it certainly doesn't help when this would be setting it back to 0. Alright. Still not getting the particular thing I was hoping for, but let's see. Because this started executing all the way through. Hmm. I think it's reading random data at that let me look at MMC again. I feel like something goes wrong. Right? I mean, theoretically, right? My code sits at 00, so doing that interrupt shouldn't actually change anything, right? As soon as I saw that, it was bothering me. So, in any case, uh, perhaps shortening the amount of cycles I put in. You go all the way from the beginning. Right. Let's make this easy for me. So, the theoretical instruction that I would come across to stop would be instruction 104. Hmm. So at the very end, we have 4, which is hex 40. So we have this instruction read, which should be 0301. This is just off. A single instruction causes a lot of issues. want to get this. Okay. Okay. What instruction do I hit? This 72. What do you know? That's this instruction. All right. CPU clock. $72. And we get this value. 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so right here is the, and I know the timer is up, but I really wish to get this. Right, we interrupt the MMC. Now we'll floor all the addresses. Time to fetch some more instructions. So, we on clock cycle 1, instruction is equal to 0, which let me double check. It shouldn't be. I'm not going to get this now, am I? You know what would probably help? Moving this. Here. There we go. That prints extra uh, extra empty line. So now it's easily separable. See how easily separable that is? That's well past the bounds. Is it? Hold on. this is about the point. Alright, I'm not getting it. It's going to be it for tonight. If you're watching the stream, thank you. If you're watching later on YouTube, thank you. It's going to be it for me. So until I see you again, this is goodbye.